Now let us discuss impulse. So what is impulse? Impulse of a force action on a body is defined as, so what is the definition? Definition is, it is defined as integration of f dt. So what does that give? Basically integration of f dt gives me the f is what? F is mass into acceleration. So mass into acceleration, which gives us mass into dv by dt. Now we had defined impulse as the force and product of that small time, and when time is changing from t1 to t2, then I can integrate and I can get the full impulse. It is written as J. So J is the capital J. It is a letter to represent the impulse. So impulse is basically f dt, integration f dt. F is nothing but ma. Ma is m dv by dt. And when you multiply with dt, this gets cancelled. And when we have to integrate this, so this is integration m dv. What if our mass is constant? If our mass is constant, it is integration dv, which is, what is integration dv? Integration dv is a small change in velocity, and when we integrate it, we get full change in velocity. So it is m delta v. So impulse J is also defined as m delta v. What is m delta v? M delta v is basically m into v final minus m into v initial. So that is p final minus p initial. So it is change in momentum. So impulse is nothing but change in momentum. Impulse is defined for a force. Impulse is defined as a product of any force into duration for which this force is acting, and at the end result is it is equal to the change in momentum. So impulse is nothing but just it is defined as change in momentum. This is how we define the impulse of a force for a certain, which is acting for a very short duration. Now we'll say that impulse is nothing but change in momentum. Now I will say instantaneous impulse. So what is instantaneous impulse? Impulse basically acts for a very short interval, and an instantaneous impulse is an impulse which is basically just acting for a very, very small time interval, and it basically suddenly changes, discontinuously changes the velocity of the body. For example, think about a ball. When you throw the ball on the ground, so when the ball is moving down, it goes down, its velocity is continuously increasing, but as soon as it comes in contact, suddenly, instantaneously, its velocity was downward, and suddenly that changes in upward direction. So there is an impulse acting for very, very short interval, which is basically called as impulse due to normal force. So we'll discuss about that. So impulse is a force, a very big force for very short interval, and it suddenly changes the velocity. So our velocity graph, if we make the graph of velocity, so initially velocity was like, let us consider the downward direction as negative. So initially it was basically increasing. In downward direction, the magnitude was increasing, and you can say initially it was 0, then it becomes minus 10 meter per second. And then suddenly at this particular time, what happens? From minus 10, it goes in upward direction. Let's say it's going with 8 meter per second, but it suddenly becomes minus 10 to plus 8. And then again, it gradually goes up and it becomes 0. So the graph will go like that. So the velocity is suddenly changing from minus 10 to 8. So the graph is discontinuous over here. So that is what discontinuously changes. So this is an impulse which suddenly changes the velocity. It acts for a very short interval and suddenly changes the velocity. And we say impulse is nothing but change in momentum. Now let us discuss some important point regarding impulse. First thing, it is a vector quantity. As you have seen, we were writing J vector. So vector means it is a vector quantity. And what about its SI unit? The impulse is nothing but the change in momentum. What is momentum? Momentum is basically m into v. So the mass is kg and the velocity is meter per second. So the unit of impulse is same as change in momentum, and change in momentum is same as momentum. So the SI unit of impulse is nothing but kg meter per second. If we talk about the dimensional formula, then dimensional formula for kg meter per second is m1, L1 and t minus 1. So this is the dimensional formula for impulse. Now next property is direction. What is the direction in which impulse is acting? We'll say that since it is a vector quantity, its direction, impulse is nothing but change in momentum. So its direction is also along the change in momentum. So whatever is the direction of final momentum vector minus initial momentum vector, we'll say that is the direction of impulse. Next property is magnitude is equals to the area under the ft graph. We already know that integration y dx. This gives me the area under y versus x graph, and we have integration f dt. So if we take force as y-axis and time as x-axis, then the area under the graph is going to give me impulse. So the integration of f dt is nothing but area under the force versus time graph. So impulse is given by area below the force versus time graph. Next is, we already discussed, this is basically integration f dt. So now if I assume my force is a constant, so I am taking force to be a constant, I am taking average force. This force suddenly comes, it increases and then decreases. But what if we want to find an average force? So let's say this is an average force. We can take that out of the integration, and integration of dt is nothing but just the time interval. So this gives me the average force times the duration. And whatever is the direction of that force, same direction is there for the impulse, because time is a scalar quantity. Now, it is not a property of the particle, but it is measure of the degree to which an external force changes the momentum of the particle. See, it depends on the force and the duration, or we say it depends on the change in momentum. It does not depend on the particle, basically external force and time for which it is acting. Let us discuss this question. So the hero of a stunt film fires 50-gram bullets from a machine gun, each at a speed of 1 kilometer per second. If he fires 20 bullets in 4 seconds, what average force does he exert against the machine gun during this? So see, this is our hero, and he's this is some machine gun, and now he's firing some bullets in that particular direction. So how much is the impulse? So I'm saying, see, when a bullet is fired, what happens is a force is applied for a certain duration, right? And that force provides the bullet its velocity. Initially, bullets are stationary with the machine gun, but this force is the one which is providing them their velocity. So how much is the required momentum? Initially, all of them were 0. So initial momentum of the bullets, I am talking about just the bullets. So initial momentum is 0. What about the final momentum? Final momentum is mv. So mass of each bullet into velocity of each bullet. This is the momentum which is gained by each bullet. How many bullets are we firing? We are firing 20 bullets in 4 seconds. So I will say to fire the 20 bullets, the required momentum is this. And eventually, I'll say that this is 20, mass of each bullet. How much is that? 50 grams. So this is 50 by 1000. And to velocity. Velocity of each bullet is nothing but 1 kilometer per second. So this is 1000 meter per second. So this gets cancelled. And we say this is 1000 kg meter per second. This much impulse, or this is the change in momentum. What is the change in momentum of the bullets? We will say 1000 kg meter per second. This is the impulse which is imparted to these bullets in each 4 seconds. Now we will say how much is the impulse which is imparted to this hero. So I'll say impulse imparted to this hero must be same as this. See, whatever impulse is imparted to these bullets, same amount of impulse will be imparted to this also. So this hero also, and eventually this impulse, this change in momentum of this hero has to be same. So we'll say it is nothing but it is also 1000 kg meter per second. And now I will say what is the force? Force is nothing but change in momentum by time taken, and time taken to impart this much of momentum is nothing but 4 seconds. So I'll say it is 1000 by 4, and that gives me 250 Newton. So 250 Newton on an average, 250 Newton this force needs to be applied so that this much impulse can be imparted to these bullets.